Hi, and welcome to another showcase session. As always, I'm Michael Linke at the Australian Institute of Architects, and it's great to have you with me again. In this session, we're going to feature Australian sustainable hardwoods. We know them as ash, and I'm pleased to be joined by Daniel Wright. Daniel is their Director and National Business Development Manager based in Melbourne. Daniel, welcome to our showcase session. Great to have you with us.
Thanks for having us, Michael. Great to be here. And thank you to Australian Institute of Architects for inviting us to talk. We're going to talk about MASSLAM and an introduction to MASSLAM specifically. So I'll get straight into it. As Michael said, my name's Daniel. I'm a director here at ASH. We are Australian Sustainable Hardwoods, or ASH for short. And this is one of our facilities out in Gippsland. So what we are is a large vertically integrated hardwood processor and manufacturer. We're a privately owned sawmill and manufacturer. We employ just under 200 people, and we process serious volumes of timber, about 120,000 cubic meters of certified managed forest products. And we manufacture those in up to 8 different manufacturing facilities. I'm just going to talk about MASSLAM today. But as you can see, this one here, this is one of our facilities in Gippsland. We've just invested in another operation in Tasmania, which is right in the middle of a maturing plantation hardwood estate. So that's something that we'll start to promote and grow in the future. Of course, all the statements we make, all the products and claims we have are third-party verified, so PEFC certified, ISO 14001, 45001, etc. We can talk about that a little bit more. These are the sort of things you would have historically known us for and are still available. So our architectural timbers, furniture timbers, things like laminated stair components to the stair manufacturers, but engineered flooring, veneers, that sort of stuff. But again, we'll talk about our mass timber products down the bottom left here today. If you were to jump on the website quickly, you can see some of the timber species that I mentioned as well. You can do that in your own time, or reach out to us and we can run through some of the options direct. This is the MASSLAM line, or one of the MASSLAM lines. That big red and yellow box you can see there is the CNC, the robotic CNC component at the end of it. You can see the finished products that come out. That machine there has over 160 different tools, drills, saws, mortising, those sorts of things. I'll cover that off in a little bit later on. We have our hand up for our third CNC coming as this space grows and popularity grows within Australia. What we'll cover today is, what is MASSLAM? Why do people use it, the process, and how does it compare perhaps to international products? These are the questions we typically get asked when people want an introduction into mass timber. So first of all, what is MASSLAM? This is a visual representation. This is a Class 5 office build out in Bendigo, project we've got coming to completion at the moment. You can see big columns and beams tied in with CLT floors, massive roof structures, and a new product coming through, which is advanced timber composite floors. Really smart, efficient use of timber to get a high performance flooring system that has good acoustics and fire performance. So yeah, what is MASSLAM? MASSLAM is our ASH, our range of mass timber columns, beams and floors, intended for large structures, ideally commercial, but designed and manufactured for assembly. I'll cover off what that means in one of the later slides. So to start with, what we like to do is we'll take a lead in conjunction with the design team, engineers, architects, builders, and create a model. We build a structure in virtual reality, and we do that collaboratively. And we do that because this 3D model feeds our technology. It's what runs the robots. It's what runs the CNCs. This information needs to be frozen before it goes into our equipment. And you'll see we get right down to the nuts and bolts, literally. Everything is millimeter perfect, the screws, the dowels, the brackets. And what that does is it helps the entire team understand how this thing's going to be built, any clashes, things that would normally be worked out on site inefficiently. We work them out, we build it in the boardroom, is what they say. But we create a cut list from this, shop drawings for all of the individual parts, but even ordering lists for screws and brackets and those sorts of things. So we can get right in front of the build. It's one of the reasons mass timber is so efficient. That model, in as far as the timber is concerned, we create a shop drawing for every single part. This is an example of, say, a beam. The shop drawing would be entered into the robotic CNC's software, Cambium in this case, and the Cambium software will look at using the right saws or drills or the right tools for the job. And our technicians might override that. They'll review that and see if they can perhaps use it a more efficient way so that we're getting more timber through, so it's not a bottleneck. They might look at opportunities to increase quality or tear out and those sorts of things. That video was to show how those CNCs work. You can get an understanding of the technology that's involved and the accuracy. What comes out from the back end, that then goes through to our finishing sheds where we'll apply a coating. You can see here the red tape on the end. That's a one-way vapor permeable wrap so that we're protecting the end grain from moisture loss. Pre-attach the connections, and the black tape you can see there is a intermittent fire strip embedded within the sacrificial char depth. So this has an FRL, a fire performance level of 120 minutes. So these are quite a well-finished solution delivered to site. And then, because we're working with the installers and the builders, we'll be packing these up and coordinating, but also delivering these things in order of lifting sequence, if that's what's required. So you can see here an example of our truck loading plans. So why do people use it? Well, I mean, there's a number of reasons, and everyone has their own, but these are some of the more common things that we're told are motivators. The first, and probably not so obvious, is that mass timber is the aesthetic. It's the structure, but it's also the aesthetic. Normally in traditional structures, concrete and steel, we might be asked our joinery products to come in and cover those up so that those structural products can become more architectural. One of the real advantages of mass timber is that it is the aesthetic. It's raw, it's honest, and there's advantages in being able to express that. The other thing is, by doing that, it's a responsible use of materials. You're not bringing in extra materials just for aesthetics. You're using less materials to get the same outcome. But as you can see here, the architectural joinery is also matching the structural products, which is quite unique for us. Something that a lot of softwood mass timber from overseas, typically you don't use that softwood for the architectural joinery. So we're able to give a number of solutions which do, quite unique to us. Another reason is something that we all intuitively know. Well, I think most of us intuitively know. People love timber, and there's documents out there now that verify that. It's not something that just has to be intuitive, but this specific document here shows or compares working environments with greater than 60% visibility of wood in the environment versus less than 20, and you can see the human reactions to those different environments are quite different, and the benefits of having timber in those and biophilia is great. It can't be overlooked. Even when you break down into the positives or negatives associated with different materials, warm, relaxing, genuine. Obviously you can see from this graph, wood comes up in front, but even the negatives, cold, harsh, boring, again, wood comes up in front. Again, these are things that we intuitively know, but it's good to see them here to help drive real decisions, real value for clients. Importantly, for the QS maybe viewing this presentation, they can be cheaper and should be, I'll say, in particularly in commercial structures. So this is one of the guides out there that you can read. Again, we can provide access to this if anyone wants to reach out, but this is one of the early cost engineering of mid-rise timber buildings documents, and it compared 26 of the earlier projects. The industry's now matured even further than this, so the results are now better, but this specific document even back then found a number of benefits if you're doing mass timber construction. So, I mean, you can see these here, I won't list through them. Importantly, and probably the major factor for most people, is that mass timber tackles climate change. Depending on which document you read from around the world, this one here by the CEFC states that our industry, the construction industry, is responsible for 39% of carbon emissions. Obviously something we really need to pull our socks up as an industry and deal with, but also an opportunity. And this same document explains that if we were to swap out traditional construction with mass timber, or engineered timber as they've called it here, if we were to swap 50%, we'll get an 11% reduction in the build. So a huge result. And this is one of the main motivators for people using mass timber. Another is closed loop. It's closed loop cycle is circular economy is one of these buzzwords we're seeing now, but the timber industry has been talking about this since, well before my time. Mass timber, we're designing projects now that can be disassembled and reassembled in 50 years' time. So the cycle lives on, but we all know timber recyclers. These big elements are very easy to recycle and repurpose into various timber products at end of life. But even in the worst case scenario, you can create energy, or if it goes into landfill, for example, the carbon that's emitted at its very worst case scenario is then recaptured in our regrowth forest. So it's a perfect closed loop. But in our case, our sawdust that we use from production, that creates 85% of our energy needs, and then again that's captured in the forest. So it's a really good story. And of course, in using mass timber, it has one of the lowest embodied energies of all materials. This is the construction pyramid from the Royal Danish Academy. You can see engineered wood products here have a very low embodied energy. And I mean, this all amounts to a really good story. That first image I showed of a project out in Bendigo before, that used a beautiful regrowth hardwood. There was about 1,004 cubic meters of columns and beams in that project, and that specifically stored more than 350,000 kilograms of carbon. And that volume is regrown in our regrowth forest in less than 5 minutes. So this is why you see the timber industry talking a lot about wood being the ultimate renewable, all of these things coming together. From a social procurement perspective, for those doing particularly big government projects, where all of these, the investment in these buildings or these public buildings, they're looking to have those benefits, the economic benefits flow through the community. We're able to do these in this case, greater than 97% local content, Victorian. The only thing that was from overseas was the glue and some of the screws. We can actually do better than that if that's a requirement. And we do this in the 7th lowest ranked LGA in Australia. So it's creating opportunities, these great flow-on opportunities in some of the most underprivileged regions in Australia. These are some of those requirements you might be asked to tick the box in a government project. And of course, mass timber, Australian mass timber, our MASSLAM does tick these. So the process, how does it work? You may have heard of DFMA by now, Design for Manufacture and Assembly. It's a word that gets thrown around a lot, and it really requires a change of thinking for a lot of people. But this process, prefabricating and building a model in virtual reality, demands it. So it's a really good way of coordinating DFMA. And in theory, we could, as the supplier, we could just work with the architect and the engineer to create a solution that meets the design intent. But the purpose of DFMA is to bring everyone on board. So, we're building this, the installer is confident that they can install it, and efficiently, and they have a say on how to do that. The builder the same. And that's all well and good, but the real benefit is that they also know how to price it correctly. It's one thing to come up with a great solution and a cost-efficient solution, but if the people installing it don't buy into that, then you've lost your cost savings. So this is a real opportunity to get everyone on the same table. And what you should see is a build that coordinates 30% quicker, depending on the project, of course, but this is totally realizable. And one of the benefits there is that your flow-on trades can then start earlier, and this is where you really get to push some economic value. So how that works, we'll get heavily involved if we can in schematic design early on, and these are 3D models. These aren't just lines on a page. We've got a number of engineers internally at ASH, and we do this as a free service. Once we've got to a point where everything's frozen and the building's built in virtual reality, we'll create these shop drawings, glue laminate the chosen timber species, CNC the material according to the requirements, pre-attach the brackets and coordinate the brackets, add the coatings, and then deliver to site. And this is what that looks like. This is a typical sort of project. This specific project here is going to be the largest timber building, the tallest timber building in Australia. And you can see here the design lead in, if you can see my cursor here, is about 4 to 5 months for a project of this scale. 3 to 4, 5 months, depending on the CNC requirements, the press being the orange line and the CNC being the red. And then, we're looking at getting staged approvals. So we're looking to get cut list approved during the modeling process. We can then go ahead and press, get approval of shop drawings and assembly drawings, etc. We can then go ahead and CNC or create the steel bracketry. And then, of course, delivery can start to happen concurrent through the production stage. It is a different way of thinking to traditional construction, but the efficiencies are worth the extra effort up front. For those interested in section sizes, just to get your head mentally around what's possible, this is on our website. These are the section sizes available. You can see on the left there, 450 maximum width and 1300 millimeter maximum depth. These are massive sections of timber. Put it in context, the columns we're doing for one of Australia's tallest timber buildings are 380 by 380. So 450 by 1300 is huge. The longest length we do is 12 meters, but as you can see here, we can do longer. We could do 45 meters in theory, just by use of a mechanical connection. The volume capability, and for those worried about the risks and hearing of timber supply issues or material supply issues in the world, what's unique for us is that we're in control of our supply from log to finished product. So if we know your project's coming, you'll get it. You can see there's about 48,000 cubic meters of timber in our yard at any point in time. but putting that into some context, these large columns that you can see here, these were at 550 by 550. We can do about 8,000 cubic meters of those per annum and about 35,000 cubic meters of the smaller stuff per annum. And this results in about 8 of the largest timber buildings in Australia currently, 8 of those per year. So the volume's there, and you know, we overcome the risk. I wanted to show this for those interested in the process and why we ask to be involved early on. These are essentially the same column to beam connection types. They all have the same loads and grids and spacings and those sorts of things, but you can see that they're quite different on the inside. And if you look at 2A, for example, you can see, if you actually look at the 3D render there, you can see there's quite a bit of bracketry. There's a lot of drilling and blind slots that the CNC needs to undertake. There's a lot of dowels, which also need plugs. And then there's quite a bit of QC resulting in that. If you think about that on site, how that installs, it's going to take a bit of time before the crane can unhook. Member will be dropped in, it's got to be located, then the crane can unhook. If you look at option 1, does the exact same job, but you can see there's a lot less bracketry, there's a lot less CNCing, there's a lot less CNC time, there's a lot less risk and QC and all of those sorts of things. But the crane can theoretically drop that beam off the hook and move on to the next one. So it's very efficient in comparison. And you can see the ratio down the bottom there. In fact, it's 3.5 times more efficient. And column to beam connection 2A is typically how we get asked to do things. So depending on how mature the design is, you know, we may or may not be able to really embed and engineer cost savings for everyone. So this is why we like to be involved. How does it compare to other mass timber? Well, I mean, this, again, probably intuitive, things that people already know, but some of the main things to raise is, you know, as this space grows in Australia and as we try to use building ideas to beat our climate targets, for example, where one of the things that's happening now is, if you can see my cursor down here, we're able to use technology and this momentum to start converting plantations that might have been grown for pulp and convert those into higher value, longer rotation, better carbon stores in these sort of mass timber products. And the more this grows, the more plantations. We're seeing a huge push now to get 1 billion trees in the ground by the Australian government, which has all sorts of flow-on effects. But the effects don't obviously stop there. We also do tests and R&D with universities and other Victorian institutes. I mean, the flow-on effects are huge. Of course, if you're importing this, you're exporting all of those benefits. Another thing that we get told comparative to, you know, this is from a lot of our building customers who've used us or other Australian mass timber and have also used overseas, is that there's significant hidden costs in some cases with overseas. I won't go on about all of these, but one that stands out is even treatment. 8 months of the year, if you look into the fumigation column here, stink bug, 8 months of the year, you'll have anywhere from $900 to $2,000 per container to treat for stink bug. You don't get that if you're manufacturing in Australia. And of course, if you are bringing in from overseas, we all know install on site doesn't always fall when it's planned to, but to get it from overseas, you have to warehouse that to deal with that difference. And warehousing cost does not come cheap. Double handling, forklifts, overheads, risks of damage and those sorts of things. So if you want to know more about this, please reach out to us direct and we can help out. But it's a similar thing with importing risks. And you know, time's shown that you know, using local, we're able to overcome a lot of these risks. We're in local time, and you know, we can talk direct with the design team to overcome any risk that could pop up. So that's us. Thank you. If you've got any questions about MASSLAM, we'd love you to reach out. We like to get heavily involved. please chase us down.
Thanks, Daniel. For those members who are watching this and want to get in contact, what's the best way to reach out to you?
The best way to do that would be through our website, ash.com.au. There's a number of contact forms there. And I believe my number was on the front of this presentation as well. You're welcome to reach out direct.
Perfect. That sounds great. All right. Well, thank you very much, Daniel Wright, the Director and National Business Development Manager for Australian Sustainable Hardwoods, or ASH. You can find them on www.ash.com.au. Thanks very much for joining us at this showcase session. I've been Michael Linke here at the Institute of Architects. Hope you found that showcase session very valuable. Look forward to seeing you at another session very soon. Thanks.
Thanks, Mark.